Welcome to The Explainer. Today, we are tackling one of the absolute biggest headaches modern developers face when working with AI. If you've been dealing with massive logs and hitting a brick wall with context limits, you are definitely in the right place. Today, we're looking at Headroom MCP. This tool is really stepping up as the hero for developers who want their AI assistants to run faster, smarter, and way more cost-effectively. So let's just think about your daily workflow for a second. What actually happens when your AI coding assistant just swallows way too much data? We've all been there, right? You toss in giant files, massive JSON payloads, or these incredibly dense error logs into your AI, and suddenly, bam, you are completely maxing out your token limits. Not only does the AI's performance take a massive nosedive as it gets lost in all that noise, but you are quite literally burning cash on tokens you didn't even really need to process. It's frustrating, it's incredibly expensive, and it just drags down your whole development cycle. And this brilliantly illustrates the core difference here. The standard AI approach just leaves you with a bloated context window, maxed out limits, and skyrocketing costs. But with Headroom MCP, you're essentially getting a dynamic zip file for your LLM's brain. Instead of forcing the AI to memorize the entire dictionary just to find a single word, Headroom gives you highly efficient on-demand compression. The AI only holds on to what it actually needs, exactly when it needs it. Okay, here's our quick roadmap for today's explainer. We're going to cover 1, the context problem itself, 2, the 3 core functions, 3, architecture and compatibility, 4, tracking your actual savings, and 5, a little bit of troubleshooting. Okay, let's dive into this. Section 1, the context problem and the Headroom solution. The real beauty of Headroom's MCP server is just how incredibly seamless it is. It directly exposes these compression and retrieval tools straight to the environments you're already using every single day, stuff like Claude Code, Cursor, and Codex. And honestly, the best part? It operates completely as an MCP tool, which means there's absolutely no proxy required to get up and running. The LLM can just organically reach out and call these tools the second it realizes a file is getting a bit too hefty to handle. Moving on to Section 2, 3 core functions. Let's talk about the absolute superpowers Headroom is going to give your AI. So how does this actually look in practice? It's basically a highly efficient 3-step dance. Step 1, when the LLM hits a massive file, it says nope and calls Headroom compress to shrink it down right then and there. Step 2, the LLM takes this newly compressed, hyper-efficient little footprint and actually reasons over it, doing all its heavy thinking without any of the bloat. And step 3, if the LLM suddenly realizes later in the chat that it needs those exact original details, it just calls Headroom retrieve to fetch the uncompressed file back. It is totally dynamic. Now, you might be wondering, how on earth does the AI remember what it just compressed? Well, it uses a hash. A hash is this unique key returned right after a compression happens. Think of it literally like a local coat check receipt the AI holds onto. The original uncompressed content gets stored locally with a 1-hour time to live, or TTL. So for the next 60 minutes, the AI can just slide that hash back across the counter to Headroom and say, hey, hand me that original file back, please. Let's pop the hood on Headroom compress for a second. When the LLM tosses in some content, whether that's raw text, messy files, massive JSONs, or bulky search results, the tool hands back a few crucial things. You get the compressed text, obviously, you get that all-important hash key we just talked about, but you also get the original versus compressed token counts and the specific transforms or algorithms that were applied to it. The AI gets 100% transparency into exactly how much space it just saved. And when it is time to bring that data back, Headroom Retrieve is seriously flexible. The AI passes in that required hash key, and Retrieval always checks the local store first, falling back to a proxy store if you happen to have one running. But here is the really cool part. It has an optional search query parameter. The AI doesn't have to awkwardly unpack the entire massive file if it only wants one little detail. It can just pass a query to perform a filtered search, pulling out only the specific matching items. It's quite literally surgical data extraction. All right, Section 3, Architecture and Compatibility. Let's look at exactly how Headroom wires into your specific setup. Now, what's really interesting about this slide is just how adaptable Headroom is to whatever you're running. If you're running Claude Code locally, boom, you just use the standard transport with a quick Headroom MCP install. Running a remote Docker agent? No problem at all. You can connect right over HTTP. Cursor users? You just drop it right into your MCP settings. Whether it's a basic local terminal or some wildly complex cloud deployment, Headroom just slots right in. So, depending on your vibe, you've basically got 2 architectural paths here. First is MCP only. This is your local on-demand compression where the LLM is fully in the driver's seat, manually choosing when to call Headroom compress. It's super lightweight and incredibly fast. Then you've got the MCP plus proxy setup. This is the whole shebang. The proxy actually steps in and compresses all traffic at the HTTP level before the LLM even sees it. And don't worry, the MCP tools are smart enough to operate after the fact, so they gracefully handle different data and won't ever accidentally double compress your files. For you folks running agents on completely different machines, Headroom uses the streamable HTTP protocol. It perfectly matches the MCP spec. We are talking post requests for sending JSON RPC tool calls, get requests for service and events, and delete to cleanly terminate the session. Plus, it is stateless by default. That means every single request is its own independent island, so you don't have to deal with any headache-inducing session tracking on your end. Which brings us to Section 4, Tracking Your Savings. Let's talk about the actual financial ROI here, because this is where it gets really fun. Headroom actually gives you a dedicated tool specifically for this called Headroom Stats. Call it, and you get a complete, crystal clear breakdown of your session, total compressions, total retrievals, the exact number of tokens saved, and your overall savings percentage. It'll even spit out your recent events, giving you a quick little log of the last 10 compression and retrieval actions. Basically, you are never left in the dark about how much data is actually getting crushed. And for the power users out there running complex, multi-agent architectures, Headroom totally has your back. If you've got multiple sub-agent MCP instances spinning, their stats aren't just siloed off. They actually aggregate into one combined shared file located at /headroom/sessions/stats.json-l. So you get this gorgeous total observability across your entire agentic workflow all in one spot. But I gotta say, out of all the stats returned, this one is absolutely my favorite metric. The estimated cost saved in USD. This is literally your ultimate brag sheet. Right there in your terminal, Headroom just points out the exact real-world dollar amount you've kept in your pocket by dodging token bloat. It takes this kind of abstract, nerdy concept of context limits and just translates it directly into cold, hard cash saved. Okay, final stretch. Section 5, Troubleshooting. Let's quickly knock out a few of the most common hurdles you might run into. All right, let's do some rapid-fire troubleshooting. If you get an MCP SDK not installed error, super easy. Just run a pip install Headroom AI/MCP. If your Claude environment is acting blind and doesn't see the Headroom tools, just run Headroom MCP status and give Claude Code a quick restart. Trying to retrieve data but getting an entry not found error? Remember those TTLs we talked about? Local content goes poof after 1 hour, and if you are using the proxy store, that content vanishes after just 5 minutes. And finally, if you're leaning on the proxy for retrieval, double-check that you actually started it in another terminal with Headroom Proxy. Which brings us to the end of our explainer, and a final question I really want you to chew on for a bit. How much context headroom are you actually wasting today? Seriously, every single bloated log file, every massive uncompressed JSON payload, it is actively slowing down your AI and it is costing you actual money. The tools to fix this are completely transparent. They adapt to pretty much any architecture out there, and they're ready to go right now. Thanks so much for joining me today. Definitely go check out Headroom MCP, and I'll catch you in the next one.